All right, this is on graphing rational functions by identifying the transformations. So how do we graph and transform a rational function? A rational function can be written with f of x equals n of x, which is the numerator, over d of x, which is the denominator, and both of them are polynomials. So let's go ahead and begin by graphing the parent function, which is y equals 1 over x. So we're going to go ahead and evaluate for values from -4 to +4. So we're going to substitute x in, and we get 1 over -4, 1 over -2, 1 over -1, which reduces to -1, 1 over 0, which is undefined, 1 over 1, which reduces to 1, 1 divided by 2, 1 divided by 4. So then we're going to go ahead and graph those ordered pairs. So we'll go left 4, down -1/4, left 2, down -1/2, left 1, down 1. So what happens is we get a curve forming, and then it's undefined, so we create what we call a vertical asymptote where it's undefined. So x equals 0. And then we go right 1, up 1, right 2, up 1/2, right 4, up 1/4. Again, it's going to create another curve. So this is the parent function. We also have another asymptote. It's a horizontal asymptote at y equals 0. So let's go ahead and answer the questions off to the right. There are no x-intercepts, no y-intercepts. The asymptotes are at x equals 0 and y equals 0. And then there are our domain restrictions. So if we think about domain is your x. What can x not be? It's everything but that green vertical line. So we say from -infinity to just before 0, or right after 0 to infinity. And then same thing, the range is our y, so it's that horizontal asymptote. So it's everything from -infinity to just before 0, or right after 0 to +infinity. The parent function y equals 1 over x can also be written in the form f of x equals a over x minus h plus k. And these are when we have our transformations. So in the red, if you have a negative a, it's going to reflect across the x-axis. And then if the a is adjusted, you could have a vertical or vertical stretch or compression. The k is going to move it up or down. So positive k will move it up, negative k will move it down. The last, the minus h. If we have a positive h, it's going to move it to the left. A minus h, move it to the right. So I always tell my students, think opposite on the horizontal translations. All right, so now we're going to go ahead and apply the transformations to this first function. So here's our first function, f of x equals 1 over x plus 5. So who is the transformation? We have a plus 5, which is our k. And that k is a positive number. So what it's going to do, it's going to move all of our ordered pairs up 5 units. So if we look back at our parent function right here, we're going to take this green asymptote right here, y equals 0, and we're going to move it up 5. And that'll just move all the points. So my asymptote now is at y equals 5. Now I did not move left or right, so my vertical asymptote will stay as it is, x equals 0. So what I'm looking for is just 1 point and 1 point there. It's going to create a sketch. Then our domain is everything but the vertical axis. So I'm just going to write it as short x cannot be 0. And then our range is everything but the horizontal asymptote. So that's a short way to write domain and range. It's all reals except x can't be 0, all reals except y cannot be 5. All right, here's another one. This time now we have a minus 2. So minus k is going to move it down 2 units. So we create our horizontal asymptote at y equals -2. And then we did not move left or right, so that stays as x equals 0. And then we create our 2 points. And then our domain is all reals except x cannot be 0, this vertical line right here. And then the range cannot be anything but our horizontal asymptote. Y equals -2. All right, now our next transformation is now inside the function. It's a -4. So what that's going to do is going to move it to the right 4. So our vertical asymptote is now moving to the right 4 units. Our horizontal asymptote won't move at all. It'll still just stay at y equals 0. So for short, our domain is everything but 4, and our range is everything but 0. And then we create our curves. So there's our 2 points. All right, our last one. Now we have a +3. So that's going to move it left 3. So we're going to create our vertical asymptote, left 3. So our domain is everything but that purple line. Our horizontal asymptote has not moved up or down. So our range is everything but 0. So our asymptote is at y = 0. And then we create our curves. So 1 point up there, 1 point down.